All right, so we have now learned all three methods for solving equations, systems of equations, graphing, substitution, elimination. What you are now going to start to see on your homework, quizzes, tests is that they are all going to be mixed in together. There are going to be problems where they tell you what method they want you to use, and there are going to be problems where they say, use any method you want, and you don't want to pick the one that's going to take you 7 years longer than every other method, right? So we are going to determine what is the best method for solving different kinds of systems of equations. The number one method here is graphing. Now, graphing is probably the most cumbersome of all of the methods because it requires you to have a graph. It requires you to graph nice lines. It just takes a lot of time. However, graphing can be useful in a couple of ways. The first reason that graphing might be useful for you is if your systems of equations are already in slope-intercept form. So that means they already look like y equals mx plus b. If that is the case, it might be easy for you to just graph that really quick and get it over with. Graphing is also really, really nice when I have fractions in my slope. So I want you to think about the equation y equals negative 2/3 x plus 2. Now, if I had another equation like y equals, 3/4 x minus 1, something like this, and I was like, well, maybe I should substitute this because y is isolated. But then we think about plugging this in for y, then I'm adding together fractions, maybe I'm multiplying, dividing fractions. So anytime there's a fraction in that slope and we don't want to deal with it, graphing is a really, really good option because we know that when we count slope, we're just counting boxes, rise over run. So that's a nice, easy way. Questions about graphing? The next method we learned was substitution. Substitution is my favorite. Maybe it's some of your favorite. Maybe you prefer it to elimination. I would say we use this method when the variable, it is, how would I say this? Let's say the variable is already isolated. So it's by itself on one side of the equal sign, or it is easy to isolate a variable. So let me give you this example here. 5x equals 10y minus 20, and x plus 3y equals 10. In this example, do we see that there is one variable that's easier to isolate than the rest of them? I kind of have two options here. I could divide the entire equation by 5 and get this x alone really easily, or I could subtract the 3y from this equation and get that x alone very easily. So as long as your variable is easy to isolate, substitution works. Well, substitution always works, but we also want to use substitution in this case. Do we see how when I stack these equations on top of each other, the equal signs are in different spots? So that is a case where we can't just start doing elimination. So if my equations are not lined up like we've been seeing in all of these elimination problems so far, we cannot do elimination until we do extra stuff to this. Like for example, this one, I would have to move the 10y to be on the left side of the equal sign first. So a second reason why elimination is nice, and I don't want us to necessarily use this as a reason, but it's just something for you to visually see, but the equations aren't lined up. However, when we justify why we are using substitution, I would say this top reason is the best. Questions on that one? Elimination was the last one that we learned. We like to use elimination when it is easy to get opposite coefficients, or we already have opposite coefficients. So already have or easy to get opposite coefficients. So for example, I could use 6x plus 2y equals 8 and 12x minus 3y equals 10. While I don't have opposite coefficients in this example, all I would need to do is multiply by one thing. It'd be pretty easy to get them. I would just have to multiply that top equation by a -2, right? The other reason, like a visual reminder of when we can and cannot use elimination, like this is the best reason, but secondary to that, our equations are lined up. Do we see how the equal sign is in the same spot in both of these equations? So that's another visual reminder to me that elimination is good here. Equations are lined up. When we justify in the next coming examples, I do want us to go with these top reasons, though. Don't just say equations are lined up or not lined up. Good? Any questions there? Fantastic. Determine the best method for solving each system of equations. Incomplete sentences. Explain why your choice is the best. Keywords here at the end. Do not solve. This is like what your homework is going to be like. You do not need to solve these equations. Just explain the best reason. So make sure that we are reading directions here. Yeah, go ahead. Why elimination? We already have opposite coefficients. This is what I'm expecting your answers, your explanations to look like. They don't have to be like proper grammar right now. I'm not going to be picky about it, but I do want like a good explanation. Good. What about example 2? Autumn. Fractions and equations in slope-intercept form. Perfect. Did anybody say something different for this? What's another one that could be pretty easy to do here? I mean, we would have to work with the fractions, but... Jaden? Oh, Cody? Why substitution? What's our one thing we need for substitution, James? Yeah, do we see that the y's are already isolated? So you could argue, even though I think graphing is the best answer for this, you could argue, as long as you justify yourself, that the y's are isolated. So it would be easy to substitute that. Okay? You'd rather do substitution? Oh, well then don't do substitution unless you have to. All right, what about this one? What do we think? What do we want to do? I agree. Substitution's probably the best here. Why? Lovely. How would I solve this? I would take -3y minus 11 and plug it in for x. What about example 4? Zach says substitution. Why would we want to use substitution? What's easy to isolate here? X or y is easy to isolate. Did anybody say something different? You could say elimination. Why could we say elimination here? Yeah, if I multiplied this by a -6, I would get a -6 and a +6. If I multiplied this by 7, I'd have a +7 and a -7. That's only one step. So that's not too bad. So I could argue that elimination is easy to get those opposite, easy to get those opposite coefficients. Any questions on that? This is what the whole front page of your homework is like. So I want explanations that kind of look like this. There may be more than one right answer, but as long as you justify your reasoning and have a good reason, it'll be fine.
Like on the test, if you're supposed to do something the substitution way, but you solve the elimination way and explain it, we still get credit for it.
So let me show you what these look like. So you will have problems that look like this. And I would say, like, for example, if in my answer key I said that the best way to solve this was by graphing, but you chose not to graph it, you chose to do substitution or whatever it was, as long as you explained it and you still did your substitution right, you would get the credit for it. Okay? So that's fine. However, there are problems that you're going to see on your review that specifically say use elimination or use substitution. And for those ones where it specifies, if you don't do the correct method, you will lose points for it. Does that answer your question? Do you have a question, Branson? Your quiz is Friday. Other questions? All right, take a look at example 5. What do we want to do in example 5? Y elimination. What would we multiply by? So it is easy to get opposite coefficients. Because like Cody said, we're going to multiply this bottom equation by 3 to get our opposite coefficient of a negative 12. Zoom in a little bit. So once I multiply that bottom equation by 3, I can kind of ignore this guy now. And I'm going to add together the two equations that I have. The 12x's and the negative 12x's, those will cancel. I'm left with 5y, negative 7 plus 12. And then 11 and 36, that makes 25. Divide by 5. Y equals 5. Do not forget to plug it back in. So I get 12 times, 12x minus 7 times 5 equals negative 11. This is 24. X is 2. And we're going to write that as a coordinate. 2, 5. Everybody good with that? Let's do one more. What do we think about example 6, Jade? Y substitution for this one? Y is already isolated. Perfect. When we substitute, I know it's been a couple days, we take everything, that equals our variable, so the negative 5x minus 17, I'm going to plug it in for y. We know we're doing it right if after I've plugged it in, I only have either x's or y's, but not one of each. I'm going to distribute. 3 times 17, I think, is 51. Combine my like terms. X is negative 4. We good with that? Plug it back in. I'm going to plug it into this one right here. Y equals negative 5 times negative 4 minus 17. That was a 17. 20 minus 17 is 3. Perfect. Any questions on this?